Hello, my name is Jared Skeens and welcome to the Zoom room. Today we'd like to look at Pure Maths 3, Further Algebra, Part 3, Polynomials with a focus on the factor and remainder theorems. So over here I have what the factor and remainder theorems are and then a little bit of an illustration. So the factor theorem starts off with this. If P of t, where P of t is a function, like this one over here, here's a function, P represents polynomials. So here's a polynomial function in terms of x. So if P of t, where t just represents some value, and if you evaluate function, this polynomial function for value t, and you get a 0, then x minus t is a factor of your polynomial. So that's what this is saying. If you evaluate your polynomial for a particular value and you get 0, then that means x minus t is a factor of that polynomial. For this particular theorem, the converse also happens to be true. The converse logically is not always true, but in this case, the converse is true. If x minus t is a factor, converse means you go the opposite direction. If x minus t is a factor of your polynomial, then if you evaluate the polynomial for t, you will get 0. So this goes both directions for the factor theorem. Then the remainder theorem says that if your polynomial is divided by x minus t, then the remainder is going to be P of t, meaning that when you divide your polynomial by a factor, or by a, doesn't have to be a factor, just by anything really, that the remainder is going to be the same thing as if you evaluated the polynomial for that particular value, that is the value t. So notice the relationship of x minus t, which is written more in the factor notation, and t itself, which is more the solution part. So here we're basically talking about 3 different levels here. You have your equation, or your function, p of x, so a polynomial function of x, x squared plus 5x minus 6, and you have factors, which are x plus 6 and x minus 1 in this particular case, and then you have what's called the roots, or the solutions, and x equals negative 6 and x equals 1. So here's an example of a polynomial. So what this one over here is saying, if we start with the blue one, so if we say that x minus t is a factor, so notice we said x plus 6 and x minus 1 are factors, then our polynomial evaluated for t, that is for negative 6, and our polynomial evaluated for this t, which is 1, those will equal 0, and you can see with the math that they do. So if these are the factors, then you can do this math work and show that it equals 0. If, and you work the other way, if you evaluate a polynomial for a particular value and get 0, then x minus t, so x minus a negative 6 would be x plus 6 and x minus 1. Those then will be factors of the equation, meaning they divide in equally or evenly. Then this down here for our remainder theorem, I used a little bit of synthetic division. If you missed that video, it's the part 2 video of polynomials, talks about synthetic division. That is how this works here. So if we take 1, 5, and negative 6, and we divide it by x plus 6, notice that the remainder is 0. And if your polynomial is divided by a factor, or by anything really, And what I divided by here was x plus 6. So this plus 6 turned into negative 6 in our synthetic division. Notice that the remainder, which is right here, is 0. Then the remainder is p of t. So we see that p of negative 6 is 0. We see that dividing it, we get 0. And those two are equivalent. So these concepts, this converse statement, meaning it goes both ways, this theorem, so the forward way and the converse way, as well as the remainder theorem, this gives you important information that allows you solving opportunities in figuring out some of these Cambridge problems. And then occasionally you can throw in what we learned last time about synthetic division to help you with some of those question types. So let's get into some examples and put this to practice. Okay, let's look at the first problem that we have here. And it says the polynomial 6x cubed plus ax squared plus bx minus 2, where a and b are constants, is denoted by p of x, our polynomial function of x. It is given that 2x plus 1 is a factor of our polynomial, and when our polynomial is divided by x plus 2, the remainder is negative 24. Find the values of a and b. So let's go back to our board, see what we got here. I wrote down the polynomial p of x equals 6x cubed plus ax squared plus bx minus 2. And then the additional information. Now notice this is different than in synthetic division where it just straight out asked you to divide something. Here it's giving extra information. So when you see these extra words like factor and remainder, that should clue you in that it's referring to the factor theorem and remainder theorem, and that's how you should proceed in problem solving. So because 2x plus 1 is the factor, then our p of t will equal 0, meaning our polynomial evaluated, t means like the solution to the factor. So if you solve this, you would get a negative 1/2, and our polynomial evaluated for negative 1/2 will equal 0. And over here, our polynomial evaluated for negative 2 will give us a negative 24, because it says that if our polynomial is divided by a particular factor, so here's the factor x plus 2, then the remainder is just, the remainder is the polynomial evaluated for the t, that is the solution to the factor. So evaluating our polynomial for negative 2 will give us a remainder of negative 24. Here are our two equations. Notice we're solving for a and b, and so we'll take two equations to do that. So the first thing that we're going to do is our p of negative 1/2, and when we do our p of negative 1/2, we're going to end up with and you can work it all out here. So p of negative 1/2 would equal 6 times negative 1/2 cubed plus a times negative 1/2 squared. And you can actually put those into your calculator to help you do that a little bit more quickly. And when you work all this through and get rid of the fractions, you're going to end up with a minus 2b equals 11. A minus 2b equals 11. Then when we do the second part, our p of a negative 2, meaning we're doing the same thing. On this one, though, you're going to set this one to 0, by the way. So as you work this out, at the end, you'll have equals 0. So when you simplify it and move things to both sides, you get a minus 2b equals 11. You can do the math. On this one here, if you plug in your 6 times negative 2 cubed plus a times negative 2 squared plus b times negative 2 minus 2, and here you're going to put equals a negative 24. maybe I should move this one here. We move this out of the way so it's not so crowded. Minus 2. This one is going to equal a negative 24. And so the two equations that we get from the top one, we get a minus 2b equals 11. From the bottom one, when you work that one out, you get 4a minus 2b equals 26. Then we can just subtract. So a minus 4, that's negative 3a. Here's negative, negative makes plus, the b's cancel. And when we subtract this, we get a negative 15. So divide both sides by negative 3. A equals 5. Sometimes what I like to do is if I'm dealing with an equation like this, I'll put an arrow on the side and subtract up. So it would give me 4a minus a is positive 3. The two b's still cancel, and 26 minus 11 is 15. And divide by 3 is 5. So that way you don't have to deal with all the negatives, but it's up to you. So here's our value for a. Then we plug that back into either one of these. 5 minus 2b equals 11. So 2b equals 5 minus 11. 2b equals negative 6. And b therefore equals negative 3. So we have negative 3 and 5 are our two answers. We used the factor theorem and remainder theorem to help figure this out. It's not really that difficult, but you do need to remember the theorems. There's only 2 of them, and this is basically your approach in these polynomial question types, in addition to the occasional use of the synthetic division. So let me go ahead and set up the second problem. Okay, here's problem number 2. Again, you can see the Cambridge code there at the top if you're interested in where it's from. The polynomial 4x cubed plus ax squared plus bx minus 2, where a and b are constants, is denoted by p of x. It is given that x plus 1 and x plus 2 are factors of p of x. So for letter I, find the values of a and b. Find the values of a and b. So let's go back to our board here. And so here on the board, we have our polynomial p of x equals 4x cubed plus ax squared plus bx minus 2. And it says x plus 1 and x plus 2 are factors. So what we want to do is we want to, again, remember that this should remind us of the factor theorem. So our p of negative 1, that's solving for the factor into the solution, negative 1, will equal 0, because this is the factor theorem. And p of negative 2 will also equal 0. So as we solve these, we plug in negative 1, we plug in negative 2, and when we work with these, we get an a minus b equals 6 for one of those. And then for the other one, we end up with 2a minus 2b equals 12. Now you can go ahead and do the calculations yourself. I'm just showing you the important parts of how to get through this. Then now you have system of equations. We can multiply this one by 2, and we get 2a minus 2b. Oh, that one was already multiplied by 2. The other one is, sorry, I gave the wrong one down here. This is the one, this 2a minus 2b equals 12 is the one after multiplying it by 2. And then the other one that we get from the p of negative 2 is the 4a minus 2b equals 34. So if we subtract these going up so that we end up with a positive here, we get 2a equals 22. So a equals 11. There's the first answer. Plug that back in here. 11 minus b equals equals 6. So B equals 11 minus 6B equals 5. So 5 and 11 are the answers for A and B. Then I'm going to try and sneak the second question part in here. So let's go back to part 2. When A and B have these values, find the remainder when P of X is divided by X squared plus 1. So we're going to divide by X squared plus 1. Let's go back to our board. Notice I put divide by x squared plus 0x plus 1. If we're going to use synthetic division, you have to keep track of those place values. So this is our second part here. And we want this number up here. 4. A is now 11. B is 5. And we have a -2. We're going to divide this by -1. This is like x. You could write this right up here, bring the -1 down, change the sign. Here is 0. And we're going to write this down here. The front coefficient is 1, so we don't have to worry about that one. We just worry about these two. Change their sign. Now we're ready to go. So bring down the first term, 4 times -1 is -4. Where to put it? Well, there's 3 terms. Again, don't forget the 0x. So that makes 3 terms deep. So 3 terms deep, 1, 2, 3 is right here. So this is actually -4. -1 times 4 is -4. 4 times 0 is 0. That one's 2 terms deep. And add these up, you get 11. Multiply 11 by -1, you get -11. 11 times 0 is 0. 5 minus 4 is 1. And -2 minus 11 is -13. Now, where is the remainder? Well, here's a cubed divided by a square. So a cube divided by a square is just x. X cubed divided by x squared is x. So this is the x column, which makes this the constant, and that makes this the remainder. So the remainder equals x minus 13, and that's the answer for finding. Says find the remainder when you divide this polynomial with these a and b with this polynomial here. So again, look for the clues like factors and remainder as far as using this factor theorem and remainder theorem to your advantage in the problem solving. Then when they ask you a straight out division question, you can use the synthetic division to help you find the remainder. Okay, let's look at the next question. Okay, let's look at this question here. We have the polynomial 8x cubed plus ax squared plus bx minus 1, where a and b are constants, is denoted by p of x. It is given that x plus 1 is a factor of p of x, and that when p of x is divided by 2x plus 1, the remainder is 1. Find the values of a and b. Then it says when a and b have these values, factorize our polynomial completely. So let's get back to the board. Here we see our p of x equals 8x cubed plus ax squared plus bx minus 1. X plus 1 is a factor. And when you divide by 2x plus 1, the remainder equals 1. So again, these words factor and remainder go with the factor and remainder theorem. So what does that mean? So this translates into our p of -1. Again, you have to solve the factor into the solution. And so this is the t that's being referred to in the theorem. And this equals 0 because it's a factor, which means it divides evenly. There's no remainder. Then this is the remainder theorem, which means when we take our p and we evaluate it for the solution to this, which would be a -1/2, subtract 1, divide by 2, the result of this evaluation will be the remainder, which is 1. So let's go ahead and look at that. If we plug in p of negative 1, we get 8 times negative 1 cubed plus a times negative 1 squared plus b times negative 1 minus 1 will equal 0. So a negative 1 cubed is a negative 1 times 8 is negative 8. Negative 1 squared is positive 1, so plus a minus b minus 1 equals 0. That means that a minus b will equal 9. The 8 and the 1 makes negative 9, and add it to the other side. Then we evaluate our function for negative 1/2. So negative 1/2 cubed plus a times negative 1/2 squared plus b times negative 1/2 minus 1 equals, don't forget to put 1, don't put 0. This isn't factor theorem, this is remainder theorem. So equals 1. Then when we work this out, a negative 1/2 cubed is a negative 1/8 times 8 is a negative 1. Negative 1/2 squared is positive 1/4, so 1/4 a minus 1/2 b minus 1 equals 1. So hopefully you see here 1/4 a minus 1/2 b equals 3. So what we want to do is clear out the fractions. We're going to multiply everything by 4, which will give us an a minus 2b equals 12. A minus 2b equals 12. We can subtract. The a's go away. We end up with a positive b equals a negative 3. So that's one answer. Okay, so notice we multiplied everything by 4 to cancel out the fractions, the common denominator. 4 times 1/4 is just a. 4 times here, the 2 cancels, leaving you with 2, a negative 2b. And then 4 times 3 is 12. You subtract to make the a's cancel. When you subtract a negative, you add. So 2b minus b is 1b. 9 minus 12 is negative 3. Then plug that back into either one of these. A minus a negative 3 equals 9. A plus 3 equals 9 means that a equals 6. So we have negative 3 and we have 6 for our a and b part. Now it's going to want us to take this with these values. Our a is 6 and our b is a negative 3, and it wants us to completely factorize this polynomial. So let me give us a little bit of space here. Okay, now we have some space here to work. So part 2 says to completely factorize when the a and the b have the values that we just solved for in part 1. Well, the best way to do this is, since this is a factor, that means it divides evenly. So if we divide out this factor, an x from an x cubed, that will leave us a quadratic. We already know how to factor quadratics. Factoring cubics directly is a little bit more challenging. So if we can already take advantage of this, we can take our 8, 6, negative 3, and negative 1, the coefficients, and we're going to divide by x plus 1. So we bring down the 1, make it negative. We change the sign. This x has a coefficient of 1, so we don't have to worry about that. We don't need all this. So what we do, we bring down the 8. 8 times negative 1 is negative 8. It's 2 places deep. So 2 places deep puts negative 8 right here. Add this up, we get negative 2 times negative 1 is positive 2. Negative 3 and positive 2 make negative 1. Negative 1 times negative 1 is positive 1. And what do you know? The remainder is 0, which is what we want. It shows that you've done it right so far, because it is indeed a factor. You get a remainder of 0. Now, how do we know that the remainder goes right here? You have a cubic divided by x cubed divided by x is x squared. So this is the x squared. This is the x, and this is the constant, which leaves everything after that to be the remainder. Now what we need to do is we need to factor this. And the factors of 8, 1 and 8, 2 and 4, that allow us to get a 2 by subtraction. It's going to be our 4 minus 2 here. So if we factor this, we get a 2x in this one, and a 4x in this one. We want the x's to end up negative, so we're going to subtract 1, and over here we're going to add 1. So we can double check that. 2x times 4x is 8x squared. Negative 1 times positive 1 is negative 1. We have a negative 4x and a positive 2x. So negative 4x plus 2x is a negative 2x. And it says to factor it completely. So don't forget the factor that we put in right here, this x plus 1 from up here. That needs to come down. And so we have x plus 1. And all of this here now is our complete factorization. We have 3 different factors that make up this polynomial. So that's how this works. Again, look for those opportunities of whether you're using the factor theorem and remainder theorem, or whether it's kind of like even this factorization, you can use the synthetic division. Doesn't always have to be a divide this by this. It can even help you in factorization situations to come up with the values that you need for that. I've got one more problem that I want you to look at, so let me set that up. Okay, I'd like you to look at just one more problem. It's a little bit different from what we've already looked at. And here you can see that there's a part I, but we don't have the rest of the problem, because the rest of the problem actually falls into a different question type that we will get to in the future as we go down the videos of our Pure Math 3 video series. But this first part actually falls into the unit of polynomials. Here you have this graph, and there's no numbers on it whatsoever. It's a 4th power polynomial equation. It shows the equation here, y equals x fourth minus 2x cubed minus 7x minus 6, says that the curve intersects the x-axis at a, 0, and also at b, 0, shows that a is less than b. Here you can see that a is over on the negative side, b is on the positive side of the y-axis, and it is given that b is an integer. Find the value of b. Now it's only 1 point, so you're expected to be able to do this rather quickly. And you might look at this, say there's no numbers on the graph. This is a 4th power. It's a see your cubic quartic. It's a quartic polynomial. How in the world are you supposed to be able to find the value of b? Well, I'm glad you asked, because I'm going to show you how you can find the value of b. And you want to do it relatively quickly because it's only worth 1 point, but every point is valuable in the A-level exam. So here's our equation, y equals x to the 4th minus 2x cubed minus 7x minus 6. It falls under the category of polynomials. And while it does not include factor and remainder theorem, there is a theorem called the rational roots theorem. So what we're looking for are roots, because our values of a and b fall on the x-axis, therefore they're roots, and a is less than b. And what we're particularly looking for is the b, and it's said to be an integer, and I added positive because we saw on the diagram it was on the positive x-axis, not the negative x-axis. So we're looking for a positive integer. So rational roots theorem, meaning we're dealing with a rational root, which can be put as either a fraction or an integer. So for a, we don't know. A could be irrational for all we know. But b, because it's an integer, it's definitely a rational root. So to find the rational roots from a polynomial, this is the theorem. You take the plus or minus factors of the constant, which is this 6 in the back, -6, and you divide it by the plus or minus factors of your lead coefficient, which is your A term, which is this understood 1. So what we're looking for are plus or minus 1, the factors of 6. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are the factors of 6. Factors mean they divide evenly, 1, 2, 3, and 6, divided by the plus or minus factors of the lead coefficient, the A term, which is 1, so plus or minus 1. Well, obviously, if you divide anything by 1, you just get itself. So we just have 1, 2, 3, and 6. And because we're on the positive side of the graph, then really we're only looking at the numbers 1, 2, 3, or 6. That is our list of possibilities. This is what the rational roots theorem does. It only provides for you a list of potential candidates, and we were able to reduce it down to 4. So now what you want to do is see which one of these will give you a 0 as an outcome. So we take our y evaluated at 1, and when you check 1, you get 1, minus 2 is a -1, minus 7 is -8, -8 minus 6 is a -14. So that one doesn't work, and you go to the next one. Actually, you can just put it in your calculator and have your calculator save it so that you don't have to redo it every time. So let's look at 2. If you have 2 to the 4th power, hopefully you already know how to do it so that it's saved in your calculator, and then you just go back and change the numbers. So basically, when you get over to the 3 is where you're going to end up with the 0. And so B is 3. The answer to B is 3. So you can go calculate it yourself. Plug in each of these values into here. Just write it into your calculator. Change out the x's for 1, 2, 3, 6. And you'll find out that the 3 is the one that gives you 0. You want to do it quickly, only worth 1 point, but this is how you do it. So again, thank you for joining me in the Zoom room, and hope to see you again next time.